Welcome to the world of containerization, a game-changer in how we develop, deliver, and manage applications. Just as shipping containers revolutionized global trade, software containers streamline application deployment, ensuring consistency and portability. Think of it as a digital shipping crate, securely packaging software for smooth transit across different environments. Envision the possibilities as we dive into this transformative technology. In a world plagued by the infamous developer lament, "It works on my machine," containers emerged as the hero. Before their arrival, applications would thrive in development only to crumble in production due to pesky OS, library, or config disparities. The result? Endless hours squandered on debugging rather than innovation. Enter containers, the solution that bundles an app with its very essence: code, runtime, libraries, dependencies, all snugly packed into a single, portable entity. This ensures seamless performance across all stages, from your laptop through testing to the grand stage of production. No more mismatched environments, no more headaches. Just smooth sailing, everywhere. Imagine a world where your code effortlessly transitions from development to testing, staging, and production without a hitch. Developers craft and test their code in a container, ensuring consistency throughout the process. This same container seamlessly progresses through automated tests in the CI/CD pipeline, moves to the staging environment for final checks, and ultimately serves real users in production. By maintaining identical containers at each stage, you can bid farewell to environment-related bugs and confidently deploy your work. Seamless, efficient, and bug-free transitions at every step. Ever wondered how containers stack up against virtual machines? While both offer isolation, their underlying mechanisms diverge significantly. Picture this: containers run on a lightweight runtime and share the host OS kernel, promoting efficiency. Conversely, virtual machines rely on a hypervisor and necessitate a full guest OS, making them comparatively heavier. In essence, containers streamline resources by leveraging the host OS, while virtual machines operate more independently. This distinction is pivotal in optimizing computing environments. Ever wonder about the stark differences between virtual machines and containers? Virtual machines are like standalone houses with their own complete setup, from the OS to heavy resource usage, taking minutes to boot up. On the other hand, containers are akin to secure apartments in a building, sharing the host OS kernel, booting in seconds, and offering lightweight resource usage. While VMs provide strong isolation through hypervisors, containers offer process-level isolation but require matching the host OS kernel type. So, whether you prefer the individuality of houses or the efficiency of apartments, understanding these distinctions is key in navigating the world of virtualization. Ever wondered when to choose between virtual machines and containers? If you prioritize maximum security isolation, different operating systems, or legacy applications, virtual machines are the way to go. On the other hand, if fast deployment, scaling, and resource efficiency are key, containers are your best bet. Interestingly, many organizations leverage both technologies simultaneously, with containers often nested within virtual machines. Balancing strengths to maximize benefits is the name of the game in modern IT infrastructure. Ever wonder how container images work? Think of them as the ultimate recipe for creating containers. They hold everything needed to run an application, code, environment, libraries, in a single, efficient package. Layers in these images are like layers in a cake, each one representing a specific change or addition. This approach makes images easy to store and share. So, next time you use a container image, remember, it's all about those layers working together seamlessly. Ever wonder how images are structured in container technology? It all starts with the base layer, typically a lightweight operating system like Alpine Linux or Ubuntu. Next, we add dependency layers, with runtime environments, libraries, and tools for your application. Then comes the application layer, housing your code, configuration files, and scripts. When the container is launched, a writable layer allows for runtime changes. Each layer is cached, so rebuilding an image only recreates modified layers, streamlining the build process. By organizing images in this layered approach, builds are faster and more efficient. Ever wondered how Docker builds images? It's all about Docker files. These text files provide step-by-step instructions to construct images layer by layer. Let's take a peek at a basic Docker file for a Node.js app. Starting with a Node.js base image, we set the working directory, copy package files, install dependencies, add application code, expose a port, and define the start command. Each instruction forms a new layer, so the order is key. Put your frequently changing layers, like code, at the bottom for optimal caching. Think of it as building a digital sandwich, layer by layer, with your code as the tasty filling. And remember, the key to efficient image construction is in the order. Ever wondered where container images reside? Enter image registries, the central hubs for storing, sharing, and pulling container images. Docker Hub reigns as the go-to public registry, boasting millions of images, including official ones for various languages and frameworks. Public registries like Docker Hub and GitHub Container Registry offer open access to anyone seeking images. For a more secure approach, turn to private registries such as AWS ECR, Azure ACR, and Google GCR, ideal for safeguarding proprietary images. If self-control is your game, consider Harbor or Nexus for running your own registry on-premises. These diverse options cater to different needs, ensuring a tailored fit for every user. Docker, the container platform. What makes Docker stand out in the world of container technology? It's not just a concept. Docker offers a comprehensive toolkit that has revolutionized container development. At its core are key components like the Docker engine, CLI, desktop, and hub, streamlining the containerization process for developers worldwide. With Docker, creating, running, and managing containers becomes seamless and efficient. Think of Docker as your all-in-one solution for containerized development, simplifying the way you work with containers. Ever wondered how Docker actually works behind the scenes? Well, it employs a client-server architecture where the Docker client communicates with the Docker daemon. This daemon takes care of the heavy lifting, like managing containers and images. Additionally, there's the registry, a vital component that stores and serves images. The Docker client sends commands to the daemon, allowing for seamless interaction. Whether they reside on the same system or are connected remotely, this architecture streamlines the process of building and running containers. In essence, Docker's architecture is a well-oiled machine, with the client and daemon working in harmony to simplify container management. Ever wondered how to wield the power of Docker in just a few keystrokes? Let's unveil the magic with essential Docker commands. To craft your image, simply execute docker build tmyapp 1.0 to bring your creation to life. When it's showtime, ignite your container with docker run p3000:3000 myapp 1.0, seamlessly mapping ports for a flawless performance. Dive deeper into container management with Docker PS, Docker Stop Container ID, and Docker RM Container ID to list, halt, and remove containers effortlessly. Elevate your image game by fetching with Docker Pull Nginx latest or showcasing with Docker Push Registry/myapp 1.0. Docker mastery is at your fingertips. Ever wondered how to seamlessly manage your Docker workflow? Let's break it down step by step. First, write your application code and craft a Docker file to define your environment. Next, build your image using Docker build to bring your creation to life. Then, push your image to a registry for easy sharing and deployment. Finally, deploy your image anywhere you need, be it in development, staging, or production. This comprehensive process ensures a smooth transition from development to deployment. Master your Docker workflow and watch your projects soar. Ever wondered how containers actually run? The container runtime is the behind-the-scenes maestro, orchestrating isolated environments, managing resources, and executing processes. When you type Docker run, it's like setting the stage for a performance. The Docker daemon taps into a container runtime, such as Containerd or Runk, to kickstart your container. Picture this: the runtime collaborates with the Linux kernel to carve out namespaces for isolation and groups for resource boundaries. It's the unsung hero making your containerized applications dance seamlessly. Ever wonder how containers actually work behind the scenes? Well, it all starts with the creation of isolated namespaces by the runtime, ensuring each container has its own space for process IDs, network, and file system. Meanwhile, resource allocation is managed through groups, which control CPU, memory, and I/O resources available to the container. As image layers are mounted as a union file system, a writable layer sits atop for any changes made during execution. Inside this isolated environment, the application process kicks off seamlessly. And throughout this entire process, the runtime diligently monitors the container, handling restarts and managing its lifecycle. Containers truly are a marvel of efficient and secure application deployment. Ever wonder how containers manage to stay in their own lanes without crashing into each other? Enter container isolation mechanisms. Namespaces create separate views of system resources for each container, ensuring they have their own process tree, network interfaces, and file system. Control groups step in to prevent one container from hogging all the CPU or memory, keeping things fair and square. And don't forget about the security squad, SELinux, AppArmor, and SecOps profiles, standing guard at the kernel level, limiting what containers can do. These Linux kernel features were here long before Docker, showing that containers are built on solid OS foundations, not just smoke and mirrors. In a nutshell, container isolation mechanisms are the unsung heroes that keep the container ecosystem running smoothly. Do you ever face the frustration of works on my machine issues in software development? Containers can put an end to that forever. With containers, you can start applications in seconds, significantly boosting speed. They also enhance efficiency by allowing more applications to run on the same hardware. Plus, the portability of containers enables easy workload migration between clouds and environments. Need to scale up quickly? With containers, spinning up hundreds of instances is effortless. Embrace containers for seamless integration into your CI/CD pipelines and automation processes. Experience the power of modern development with containers. In the dynamic realm of container usage, real-world applications abound. Picture a world where each microservice operates within its own container, fostering autonomous development and seamless scalability. CI/CD pipelines effortlessly build, test, and deploy applications within consistent containerized environments. Transitioning to the cloud becomes a breeze as legacy apps are neatly packaged in containers for swift migration. And on the development front, new talent can hit the ground running with instantly accessible, pre-configured containerized stacks. These versatile containers are the linchpin driving innovation, efficiency, and agility in modern tech landscapes. So, harness their power, and watch your possibilities expand. As we wrap up, let's recap the key takeaways on containers. They package applications along with dependencies, ensuring consistency from dev to production. Unlike VMs, containers are lighter, thanks to sharing the host OS kernel. Images are built in layers, defined by Docker files for easy sharing. Docker offers a complete toolkit for building, running, and orchestrating containers. The container runtime leverages Linux kernel features for isolation and resource management. Containers are now indispensable in modern software development. Dive deeper into Kubernetes, networking, and security best practices. Embrace containerization for a more efficient and scalable future.